All right. Next up, a gentleman that needs no introduction. Porter Adams from MatterLabs, zkSync, speaking about Airbender. So welcome to the stage, Porter. We're going to talk about zkSync's Airbender, Fullstack zkVM customizations.
Great.
You can just advance with the keys.
Awesome. Thank you all for having me. I'm super excited to talk about Airbender. We've had some really cool announcements as of yesterday, so I will get right to them. And then I will connect it to ETH Proofs Initiative and the entire Ethereum ecosystem, just talking about Fullstack zkVM customizations in general. So we did it yesterday. Airbender proves Ethereum with basically a toaster. We have our 2 GPU benchmark over there on the left, and just to show that we can get it under 12 seconds, we have our 8 GPU benchmark on the right. So we're very, very pleased with these numbers. I know some people I've learned have $100,000 of GPUs at their houses. I do not. So for home proving, for me, 2 GPUs sounds much, much more reasonable. And we can also start scaling Ethereum and raising the gas limits sooner, thanks to much lower hardware requirements for this. So, yay, we did it. Now, I do just want to do a little victory lap on stage while I'm here, which is to not underestimate the progress of zk. 6 months ago, there was a very serious post on the Ethereum Magicians forum about relaxing prover hardware requirements for the next few years. And I, of course, thought this was very silly. I don't know if anyone listened to me back then. Hopefully, you will understand now. Some teams will achieve real-time at-home proving before 2025 is over. We've done it. And so, of course, now the question is, if we scale the gas limit, though, zk performance also needs to get better. And my bet is that, you've seen how far zk has come in the last 6 months. I think the progress is going to keep continuing, and I think zk progress is moving way, way faster than these people will get together and raise the gas limit. So it's my challenge to you all, Ethereum ecosystem, raise the gas limit as fast as you can, try to keep up with zk. So just to kind of map out the hardware requirements getting lower, we're trying to shift everybody over to the left side of the screen where we just have 2 GPUs and keep that proving time down as low as possible. So really great work by the MatterLabs cryptography team. Especially want to shout out to them. The engineers worked super hard on this, and so yeah, super proud of their code. And basically a toaster is from Justin Drake, so if you don't like that, be mad at him. He's the one who said it. Okay, now I'm going to explain how this was all possible. Quick background first on zkSync OS. This is so previously, we had zkSync's prover and sequencer code bases were 2 separate things. We kind of wrote a fully optimized prover, and then separately we had to write our sequencer. And every upgrade, we had to upgrade the sequencer and then upgrade the prover and then make sure that they still matched. And this was a horrible way of doing things and actually limited the number of upgrades we were able to do to zkSync, which was very painful. So we've replaced all of that. Now we've worked with sort of an abstracted execution layer. So the prover and kind of the execution layer are all separate. We will compile the execution layer to x86 and run it for the sequencer. We will compile the execution layer to RISC-V for the prover. This whole sort of architecture here we call zkSync OS. It includes a bootloader to start the system. What happens in the system stuff is input-output handling. That's going to be the same regardless of which execution environment you're going to use. You're going to need some inputs and outputs. And the slide kind of hints at that we will be able to support multiple execution environments. So if people are interested in WebAssembly or other things besides EVM proving, that is built in to kind of be a modular code base. So that's zkSync OS. This is going to come back again in a couple slides. Airbender. This is our new RISC-V zkVM. I don't know if it's still new. I think it's pretty new because it's not quite on mainnet yet, but here we are. So anyways, the instruction set, RISC-V 32IM, arithmetization, AIR, proofs, Starks, Fry, commitments, Mersenne 31 prime, Blake Duess hash, and just a regular permutation argument for the memory argument. And so whenever people come to me and say, Porter, Airbender, great job on all the benchmarks, you're super fast, you must be using some crazy cryptography or something. And then I show them this, and everyone says, that's the same stuff that everyone else uses, and this doesn't really answer any of my questions. So isn't this like kind of the same as everybody else? Like, where does the performance really come from? Full stack zkVM optimizations. Title of the talk, I promised. So I want to start talking about how Airbender is like kind of co-designed with the hardware in mind. We really focus on this in like extreme detail of like every aspect of the hardware. How fast can we like pipeline things to the GPU? How much size, like what size data structures should we use to fit inside the GPU? And like everything is done with the hardware in mind. That's kind of vague, so I just want to show you a little example from one of our chats. Alex Vlasov, our co-founder, is asking a question about GPUs. We would like to use 5090s for RAM reasons. That improves recursion arity at later stages. Recursion's like how many circuits can we kind of compress down at once. Is that fine? 5090 raw computational performance is plus 20%, top of 4090, as I explained. So, and then Justin Drake turns us down. 5090s are great for cluster proving, but for the single GPU tab on ETH proofs, they want to keep using 4090s. Alex Vlasov says painful. Now, for most people, like it's just a 20% performance hit. Like, what's the difference between an RTX 4090 and RTX 5090? Like 20%, like big deal. But we've written our code so that it like fully maxes out the space on a 5090. And when you just take away that 20% space on the 4090, now you have to kind of chop things up, and like maybe it doesn't fit in memory anymore. And so like that's going to slow things down, and then like it's going to slow down recursion later on because now you add like, yeah, it's just everything kind of goes wrong. So we really try to optimize like all of our choices from the beginning have been specifically about the hardware. So we also optimize the cryptography a lot. Don't waste any circuit variables, any RISC-V cycles. There is kind of some interesting work there, but not everything fits in the presentation, so got to go quick. I think this applies to lean Ethereum a lot because we're going to want eventually probably hardware diversity and zkVM diversity. And so if we want to run like any zkVM with any hardware, like already Airbender takes like a performance hit if you use 4090s instead of 5090s. And if you want to use like, you know, different types of processors besides CUDA or something, there's probably like a lot of work to do here. And my point is just that like you will lose some performance. My like probabilistic outcome is just that everyone's going to wait until ZK is so good that it's okay to take this performance hit and have the diversity. But it is interesting to note as we think about the long term how we're going to match different hardwares with different provers. zkSync OS and Airbender were designed together. So something relatively unique that Justin mentioned this morning about Airbender and zkSync OS is like we don't just take an L1 execution client like Reth and compile it and be done. We've written our own kind of execution client for the EVM within zkSync OS. And so this, I think, has led to like a very optimized kind of simple code base that is easier to prove. I mentioned this in the panel this morning too, but the regular L1 clients haven't really been written kind of with proving optimizations in mind. And so like they've been written for normal hardware, which makes total sense for them. But as we switch over to this, probably like the L1 teams and the ZK teams are going to have to kind of collaborate together to make sure that we get all the optimizations across. One cool thing to note about zkSync OS is that we're able to do double resource accounting with both the EVM gas costs and the prover gas costs. So a lot of ZK teams will whine about like the gas costs of specific opcodes. I'll still do that at the end of my presentation. We should change them. But it's not a big deal for zkSync chains because we can just track both costs and like charge appropriately. All of this, I think, is going to be very solved by lean Ethereum. There's kind of lots of ways to match the L1 client teams with like all the ZK teams. RISC-V, like native code inside Ethereum feels kind of far off, so I won't really address that. And then, repricing the gas costs is going to take like 5 minutes once we decide to do it. So not really worried about any of the things in this slide. Just interesting to think about. Cool. I will give some suggestions to Ethereum. We strongly request that we change the Merkle Patricia tree to something more ZK friendly. Ideally, all the values in the tree would be constant, like non-variable sized. Adjust the gas costs specifically for these opcodes. We want the explicit code length in the accounts. This is going to help with checking the code for smart contracts inside the zkVM. Knowing that is quite nice for proving. And we don't like the catch hash function. If we switch to binary trees, strongly prefer Blake 2s. Cool. Just want to say, zkSync is very proud to help Ethereum. Million TPS, real-time proving, home proving, believe in something. This is all coming. Like, the progress in this field every single day is really amazing, and it's really cool to be part of this industry and this ETH Proofs initiative to help make this all happen. So with that, thank you very much.
Great, thanks, Porter. Okay, we've got some questions. Got 5 minutes to get through this. I think you got quite a few. How is 17 seconds average real time with 12-second slots?
It's a little slow. That's why, yeah, the 2 GPU benchmark is probably not quite there. We probably need 4 GPUs long term. We did 8 because obviously we got this kind of ready like yesterday. So 8 just shows you like, all right, we actually can cross the threshold. We do have a lot of optimizations still to come.
Both are on ETH proofs, right? The 8 and the 2.
Yes. Yeah. So there's still optimizations to come. But yeah, I would say it's fair to say that the 2 is not quite real-time proving as of this moment. But by the time people like watch this video on YouTube, we might be there. So.
Awesome. Okay. Do you think that Airbender can forge a false proof? Do you think I can forge a false proof for Airbender with a toaster as well?
I think it would be difficult. I will say, like, I would challenge, like, I know people are still worried about the security, and we will, like, improve the number of bits, but I think I could find a bug in any of the zkVMs faster than someone could do 2 to the 80 like bits, like breaking security by just using large computers. So yeah.
Excellent. Thanks very much.
All right, thank you.